Good morning, friends. In today's lecture, we will study that how can we draw a signal flow graph from a given block diagram. However, while drawing a signal flow graph from a given block diagram, you have to just take care about the following points, that you have to replace the adjacent summing points and takeoff points by a node. Or the condition is that you cannot replace a takeoff point preceding the summing point in the direction of signal flow. Replace the block transfer function by a line joining the respective node, and the direction of signal flow is indicated by an arrow in the line. Okay, take an example. Here in this example, there are two summing boxes. Let us suppose the summing box are named as S1 and S2. And there are two takeoff points. Let us suppose these are names as T1 and T2. Okay. Now, as far as the rule is concerned, you can consider these two points, that is summing point and takeoff point, as a single node. However, you cannot join these two takeoff points and summing points and cannot be considered as single node. So in this case, you have to take separate node for this one and separate node for this one. Okay, so in this way, if we draw the signal flow graph, then you can easily draw it like this. So this is S1 and T1, both are replaced by this node, and then after that, here this is G1, and this is your T2 node. Then here this is your S2 node. The transmittance between T2 and S2, you have to consider it as 1. Okay, so after that, it is C here, and this is 1, this is 1. Now for this part, that is for this forward path G2, you have to draw a line starting from S1 T1, that node, that is from this point, and you have to end it up to this node with the same direction G2. Okay, and here there is a minus sign here, so you have to draw a feedback path with a line starting from T2 node, which ends on the S1 T1 node, and with a transfer function h1. However, you have to take care about this sign. This sign is to be considered and added with the same transmittance. Okay, so in this way you can connect, or sorry, you can draw the signal flow graph of this question. Now take another example also. Here it consists of three summing boxes. Let us suppose the summing boxes are named as S1, S2 and S3. Okay, so you can, sorry, you have to take this as a separate node. You can join these two points because these, and this is your takeoff point. Okay, after summing point, so you can join these two summing points and takeoff points and consider them as a single node. Let us suppose that this takeoff point is T1 and this takeoff point is T2 and this takeoff point is T3. Okay, so in this case, node 1 is for S1, node 2 is for S2 and T1. Node 3 is for T2 and node 4 is for S3 T3. Okay, so you have to draw a signal flow graph like this. There are 4 nodes. Node 1, node 2, node 3, node 4, and then C. Okay, here this is R, this is C. Here we have to write transmittance as 1, and this is node 1, and this is node 2, node 3, and node 4. Okay, so now because S2 and T1 form the same node, so we can draw a line from this node which ends up at node 4. So this is G3, and here from node 4 to node 1 like this with transmittance as minus H1, and sorry, this is to be connected at, because this is to be connected at this, that is node 2, so it is to be like this. Okay, with transmittance minus 1, because it's a straight line here, its transfer function is 1, so due to this minus sign here, this is minus sign. And after that, for this T2 to H1, we have to connect another line or draw another line in this way like this, so it is minus H. So you can draw any signal flow graph, or you can draw the signal flow graph for any of the block diagram using these rules. Now it is very difficult to remember that which node or which summing point and which takeoff point is to be considered as a single node. So it's better to not to join the summing node and takeoff point, just take them separately. Like in this case, you can also draw the equivalent, or you can say that equal signal flow graph like this. This is S1 node, this is T1 node, this is T2 node, this is S2 node, and then this is your C. Okay, this is 1, this is R. Okay, then after that, this is S2, this is T2, this is T1, and this is your S1. Now from T2 to S1, there will be a transmittance path with minus H1, and from T1 to this, you have to consider this path, sorry, T1 to S2. You have to draw it like this with G2, and this is to be considered as G1, and this is to be considered as magnitude 1. So these both are equal actually, you and results in the same transfer function. Okay, so you can either draw this one or either you can draw this one. However, I recommend that you should draw this so that there will not be any possibility of error. Okay, thanks for watching this video.